Hi guys, okay, so we're going to do the last question now, question 6. Let's go to that one. Question 6, first question asked to, I'm here in Afrikaans. That's better. Okay, determine the derivative, so read that as the derivative or the gradient of f from first principles if, and then they give us f of x is negative 2x squared plus 3x. So let's see what the students did. Here's one attempt. So notice here the student should have just put in here that she is working, this is student 1, that she is working with x plus h. Okay, but other than that, this is correct. First we substitute every x with an x plus h, and then here and she put it, I see what she did. Okay, here problem is you should put in your expression the limit h tends to 0. You should put that in, and then x plus h, and then in there is another x, so that one should also get an x plus h. Everywhere where there's an x plus h, we should put in an x plus h. Okay, so that's where your mistake would be. So the point being, let's go to this student. This student just, student 2 just took the derivative, and you won't get any marks for just doing the derivative. You have to do it from first, and type here, okay, from first principles. Okay, then this student did it correct, I think. Notice how he starts with the derivative. Student 3 starts with the derivative from first principle formula, okay, which is the limit as h tends to 0 of fx plus h minus fx. Then he substitutes into our expression, this is our fx, so he substitutes into that expression every x with an x plus h. Then he simplifies, so he multiplies out the two brackets, then he multiplies in, okay, here you can see what he gets, and then eventually what you should get is every term that does not have an h should cancel. So there's an x squared here, there's a 3x there, there's a 2x squared there. This becomes negative 2x squared, it cancels with the 2x squared. This negative positive 3x cancels with the negative 3x there. So that in the end you should only be left with terms with h's, then like this. Okay, once you've simplified, and then he takes out an h as a common factor, and the reason why we have to have that is so that the h's can cancel, because I can't substitute h with 0 because there's an h in the denominator. But as soon as I've taken it out and I cancelled it, then and at that point, once you've substituted, you've cancelled it, once you've substituted it, you can then or once you've cancelled it, you can then substitute h with 0, and then you're left with the derivative here at the bottom. So well done to the student, he did a fantastic job, 5 out of 5. You'll also notice that this is really a very straightforward standard question. It will be in the test. I haven't seen the test, but it will be in the test, so make sure that you can definitely do this type of thing. Okay, next, evaluate the limit. Here they give us a limit, and again we just want to substitute x in there, but we see we can't. Now in the same way that we just in this case cancelled out, factorized and then cancelled out the problem, is what we're going to do here. Let's see what the students did here. Well done, student 1 factorized, and then she cancelled those. She's left with x plus h, and then she substitutes the limit of 2 and get an answer of 5. Now I know in her working out she might have written it correct, but you shouldn't leave out your limit. Just like this student didn't leave his limit until he substituted. I'm sure he did the same here. No, he didn't. Again, you have to include your limit here until you substitute. Okay, well, in this case it's x. Until, keep doing that. Okay, x tending to 2 until you substitute. Okay, so this student, excellent, well done to her. She's also getting it correct, but once again, remember to keep your limit every time, otherwise you will lose 1 mark. Okay, and I think it's only 2 marks, so rather put it in. Okay. Let's see. The student got it. Okay, so well done. 2 easy marks. Okay. The next question gives us a figure. Here they say y is equal to fx. It just means that this is the graph of y. The graph intersects the x axis at c. Okay, write down the value of the limit of x tending to c of fx. Okay, so remember what this just means. Okay, this is a knowledge question. All it means is I substitute every x with c. So we're asking what is f of c, and f of c, I go to where x is equal to c and see what is the value of y. The value is 0. So the limit of f of c, all I do is I substitute c, and then I go and see, well, what is fx of c? Okay, and we see it's equal to c. So let's see, not attempted, fx. Okay, so on the right track, attempted, but no, we want f of c, like that. Okay, and it's easy once you understand. Remember, limit just means I want to substitute it. If I can't substitute it yet, I will first have to simplify and then substitute. It's not as simple as that. It gets more complicated when you take calculus at first year. A limit just means what do I expect my value to do as I'm approaching c. So as I'm approaching c, I'm expecting to reach 0. And that gets a little bit more complicated when you have functions that coming from one direction, I go this way. For example, when I look at a hyperbola, okay, if I look at a hyperbola, it looks like this, and I'm asking what is the limit when x tends to 0. The problem is, as I'm coming from the top, my limit is positive. So we write it like that. When I'm coming from the top, from the positive side of 0, my limit is infinity. When I'm coming from the bottom side, my limit is negative infinity, because my graph is going to negative infinity. So we don't really do that at high school level, but this limit doesn't exist because you get 2 different answers coming from both sides. But this answer, when I'm coming from the left hand side, this side, I'm approaching, my graph is going towards 0. If I'm going from the right hand side, my graph is going towards 0. So from left to right, I'm approaching 0. Okay, determine the value of the derivative of c. Give reasons for your answer. Well, what is the derivative at point c? It's just the gradient. What is the gradient at point c? It's 0. Why? Because the gradient is 0. That's the answer. Let's see. No answer here. Let's see this one. Okay, so no answer there. And also not attempted here. Okay, guys, if you understand the derivative is the gradient, then it's super simple, because what is the derivative? This is what we read. What is the gradient at point C? What's the gradient there? It's 0, because the gradient is 0. Okay. Determine the derivative of the following expressions. Leave your answers with positive exponents where necessary. Okay, let's see. First, we had to multiply it out. X squared plus negative 3, positive 6, negative 3, positive 3, yes, and negative 18. That's correct. And then this is the derivative. But again, the student will lose marks for notation, because you don't put in that this is dx dy. The student, okay, this was not what is asked, so you're getting that correct. This is correct up to here, where you get the expression, but we're not asked to find. The only time we make the derivative equal to 0 is when we're trying to find the turning point. They just asked us for the derivative, and so all we had to do was to get the derivative, and the derivative is 2. I'm not sure, I can't read it. It's maybe a multiply. It looks like a multiply. 2 multiplied by x. Yes. So you're getting the derivative correct. That was all that was asked of you. This rest was not asked. Okay, we're not asked for a derivative. That's not a square. We're not asked for the gradient, not the derivative. Okay, so that's fine. Other student, yes, just like that. Just find the derivative. Dy dx is equal to 2x plus 3. Next question. Oh, it's only that one question for the derivative. Next question, they give us this graph, and they give us the sketch. They give us the function. First thing they ask is determine the values of x for which the function, notice it's not the derivative, for which the function is equal to 0. That just means find the, because we're making y equal to 0, find the x-intercepts, make everything equal to 0. Let's see what the students did here. Oh, this one stopped. Okay, so that one's done. Okay, yes. Very good. No, not very good, because you took the derivative. No, so be very careful, guys. It's not asking for the derivative. It's simply asking for the x-intercepts. So all we're asked to do is find the point where it cuts the x-intercept. So that's one I can then do for you. Okay. So let me just recall what's the question. Okay, x cubed minus 3x squared minus 9x minus 5. Okay, not there. Okay, so we have fx is equal to x cubed minus 3x squared minus 9x minus 5. And so we have to factorize, we have to make this equal to 0. Look, they say, where's fx equal to 0? So we just take fx equal to 0. Now we want to solve it. Because there's a 3 exponent, we will have 3 answers. And we've learned how to do this, how to factorize polynomials. And what we do is we first find at least one of the factors by inspection. So we use values, and we can look at the values of this, the what do we call it, the factors of 5. Now the factors of 5 is just 1 and 5, so 1 and 5 will both be factors, but in other words, if I substitute it in here, I'll get 0, but it might be positive or minus 1, or positive and minus 5. So obviously the easiest one to calculate is just plus minus 1. So let's start with positive 1. So 1 squared. Actually, negative is going to work better because some of these signs will change. Otherwise, everything will just be negative. So negative 1 will probably be better to use. So if I try negative 1, it's going to be negative 1 cubed is negative 1. 3 squared is, negative 1 squared is positive 1, times negative 3 is negative 3. Negative 9 times negative 1 is that positive 9 minus 5. And you see that you see how that negative 1 changed this. Everything was negative, so it was just going to be a big negative if this was still a positive 1. So in the end, this is equal to 0. Negative 4 plus 9 is 5 minus 5 is 0. Okay, so we know that x, I substituted minus 1, so x is equal to minus 1, so x plus 1 is equal to 0, so x plus 1 is a factor. X plus 1 is a factor. So now I'm left with something else. Now someone asked me to show them the k method, so let me show you the k method, if it's not going to confuse you. But in the k method is, we know that this expression is, we have a small bracket. Now we still have to have an expression with squares left. So ax squared plus, I'm not going to put that because of what I want to show you, plus bx plus c. This is what should be left here. And what makes it easy now is this. Now we can do long division to get the quotient, but the k method is a method done by inspection. So for example, the first term here and the first term here must give me the first term there, x cubed. What must the coefficient be for this first term and that first term to give me that first term? Well, this is a 1, that is a 1, and this is a 1, so it just needs to be a 1. Okay, the last term is also easy because the last term here and the last term there must give me the last term here, negative 5. Now this term is positive 1, so what can I multiply 1 with to get negative 5? It's just negative 5. Now the middle term is the tricky one, and we call it the k method because we usually just use a k for a substitute, just for now. And the reason why this is a little bit trickier, because if I look at negative 3x squared, negative 3x squared is not just the product of the x squared and the 1. That gives you x squared, but it's also the product of the x and the kx. So this one squared, x squared plus kx squared should equal, and then negative 3x squared. And so what must k be so that x squared plus kx squared equals negative 3? Well, k must be negative 4. Because positive 1 and negative 4 will give me negative 3. So that's the quick way, or the k method, of finding that. The alternative is, and now we just go and factorize further, plus 1x squared, now it's 2 brackets with this last one, equal to 0. And so what gives me negative 5? Two different values is, two different signs is negative 5 and x positive 1. And so you see I've got two answers. X is equal to negative 1 or x is equal to positive 5. And so if I go back to my question, this is then x is equal to negative 1. Okay, and this is x is equal to positive 5. Okay, now how could I have done it otherwise? The standard method that's very practiced in for you guys is to take x squared minus 9 minus 3 minus 3x squared minus 9x minus 5, and then just do long division with this. So long division, I start with dividing my first term, my x term, in there, and I'm left with x squared. Left with x squared. Then I multiply back my x squared to get x3, but I multiply it with both. x3 plus x squared. But then I subtract everything, so this becomes a minus, and this becomes a minus. So I get x cubed. Here I get minus 4x squared. And now I bring down the next term, negative 9x. Again, I divide it in, I get negative 4x there. Multiply it back, so I get negative 4x. Negative 4 times positive 1 is negative 4x. But because I'm subtracting, all the signs change, like that. And then this is 0. This is negative 5x. Bring down the last term is negative 5. And again, I divide in my x in there. I get negative 5. Multiply it back. Negative 5x. Negative 5. And this time, when I change my signs, I get 0, 0. That's because this is a factor and this is the remainder, and a factor always must give a remainder of 0. And there, as you can see, this was a long few steps, very simple and straightforward steps, nothing strange about it to get my coefficient, but it takes a little bit of time. Okay, and then just once again, once we have the quotient, I can come back here and factorize the quotient. And that gives me my two intercepts. Let's just see if they didn't ask for coordinates. No, just the values of x. Show that the coordinates of D, the turning point of F, is that. Okay, the coordinates of D. Now, when we want to find the turning point, that is when we take the derivative equal to 0. Okay, so we can close the student. 6.5.2. Yeah, you see that is where you should have taken the derivative, made it equal to 0. Then you found x is equal to 3. So you did the step in the wrong place. This is where you should have done it. Found the derivative equal to 3. And here, I think you factorized it wrong. You should have had, you took out the 3. And here, this should have just been a 6. When you got the derivative, this should have been a 6. Okay. But anyway, let's see this student. Yes. Okay, so he took the derivative and made it equal to 0. And when he did that, taking the derivative equal to 0, you get 3x squared minus 6. Then this one gives you two answers. Okay. X is equal to 3 or x is equal to negative 1. So which one are we working with? With x equal to 3. Notice that's the positive side. This is x is equal to negative 1. We already know this turning point is negative 1, 0 because we worked out that the intercept there is negative 1. Okay, but then 3. Then to prove that its point is 3 and negative 32, we just substitute 3 in the original function, not in the derivative. That will give me 0, but in the original function I substitute it, and that's where I get the negative 32 from. Okay, for which values of x is the second derivative smaller than 0? Now there's two ways of doing that. Just get the second derivative. Let's see what the student did. Okay. This is something else I helped the student do. 6.5 point. There we go. Take the second derivative. In other words, just take the derivative and derive it again. And then, I don't know why he made it equal to 0. That should have been because the question asked where is it smaller than 0. Okay, and then nevertheless he got the right answer. just take the second derivative and make it smaller or equal to 0. Is it smaller or equal? No, just smaller than 0. And then you get this expression. You take the 6 to the other side, you divide, and you get, therefore, second derivative is 0 when x is less than 0 when x is smaller than 1. Okay, and the final question, determine the values for which the function of x times the derivative of x is greater than 0. Now this sounds very complicated, but if you know what the things represent, it's not difficult. First of all, you need to understand what greater or equal to 0 means. It just means positive. So what that means is that this sign and that sign is equal. So if the sign of fx and the gradient is equal, okay? Now, fx is positive when the function is above the x-axis. The gradient is positive when the gradient is positive. So notice here, for example, here my gradient is positive, but my function is underneath the x-axis. Here my gradient is negative and my function is negative because my function is underneath them. So this would be a negative function times a negative gradient. That will give me a positive. So whenever we have two things multiplied and it gives me a positive answer, it is because the two have the same sign, either both positive or both negative. So here, from this point to that point, okay, then from here to here we have a positive gradient but a negative function because I'm underneath the x-axis, my function is negative. But here, from this onwards, I've got a positive function because I'm above the x-axis and a positive gradient. So guys, really what it comes down to is thinking. You have to think about these things to get it right. So the final answer for that is that when x is smaller or equal between 1 and 3, between those two intercepts, and when x was bigger than 5, larger than the x-intercept. So let's just again show you where I get that from. Between this point and this point, gradient was negative and the graph was negative. So between -1 and 3, this was positive 5. So after positive 5, both the gradient and the function was positive. Okay, last question. I don't think anyone attempted it. A metal frame consisting of a rectangle and an equilateral triangle, as shown in the diagram below, must be manufactured. The total length of the material to be used for the entire frame is 40 centimeters long. Express y in terms of x. Guys, and this is why it's so disappointing that no one let's go this way. No one attempted it because it's really so simple. See, I mean, the fact that you're doing it and you're not even attempting it and you don't even have time, you can look at your book, it's really disappointing. But what we have is, we have this whole frame here, okay? You can see this is x centimeters, y centimeters, x centimeters. The entire frame here together is 40 centimeters long. So it's x, 3 x's and 2 y's. So in other words, x times y times plus, not times, plus. So x plus y plus x plus y. In other words, 2 y's and 3 x's must equal 40 centimeters because they say the total length is. Now they say write y in terms of x. So 2y is equal to 40 minus 3x. So y is equal to 20 minus 3 over 2x. Very, very simple. Show that h, the height of the triangle, is given by that. So h is the height of the triangle. We should show that it's equal to that. So here is the triangle there. The height of the triangle there. Now notice that this is also just x. Okay, and so this side here is x and half of x, because the whole thing is x. It's an equilateral triangle, so this is just cutting this in half. So this is a half x, and so we must just find the height. So it is Pythagoras that h squared is equal to x squared minus, this is now the Pythagoras. So Pythagoras would say this squared plus that squared is equal to that squared. So let me do it that way, squared. So h squared plus half x squared is equal to x squared. And so h squared, sorry, I didn't finish that so that I can not maybe lose some of you. So h squared is equal to x squared minus a quarter x squared. This gives me a whole minus a quarter is 3/4 x squared. And so to take h is to take the square root of that. That should be plus minus, but because we're working with length, there's no such thing as negative length. So h is equal to, and now we can just break up the square root over every factor. Remember, you can't do it over, for example, I couldn't have done it here and then said it's x, break it up over the x squared minus and break it up over the other one. No, we can't do that. We can only break up a square root over factors. So it's the square root of 3 over the square root of 4, which is 2, times the square root of x squared is x. And that's what they ask us to do, to show us that this is given by that, and that's what I have. Show that the enclosed area A of the frame is given by, and so now all of the area here we must get. So I'm obviously going to have to just move this way. So what we have now is this triangle and a rectangle. That's y, but y is also equal to 20 minus what was it, 3 over 2x. So that was what y was equal to, and then x is there, and x is there, and x is there, and then here we have the height, and the height we have as square root 3 over 2x. Okay, so we've got two things to have area of to get the total area, and so the area is the rectangle plus the triangle, and the rectangle's area is length times breadth. The triangle's area is a half times the base times the height. Okay, so the length would then be this one, is 20 minus 3 over 2x. Okay, the breadth would be this here, which is also the base, is x, plus a half, the base as we said just now is x, times the height, we have square root 3 over 2x. And so if we simplify all this, we get 20x minus 3 over 2x squared plus, and then a half times this term would give me square root 3 over 4x squared. And you just see what was the final expression they wanted. Okay, they want us to use our calculators then for this term here. Okay, because I can add these two things together. I've got that must be a plus, sorry, that's not a minus, no it is a negative. Okay, so let's see, because that, oh yes, okay, so we've got square root 3 divided by 4 is equal to that, minus 3 over 2. 3 divided by 2 is equal negative 1.0, and then if I round those 2 decimals, it would be 0.7. So this is, after I've rounded, 20x minus 1,07x squared. Just again, notice the reason why I did that is because these have the same, they're the same, like terms. So I can add the coefficients. That's why I did that. Okay, there it is. So far, you can't say that this was difficult in the least. No one just attempted it, so there's nothing to mark. There's no thinking going on. You guys didn't think or tried at all. Hence, calculate the value of x for which the area is a maximum. Okay, and this is the only one where I'll say is difficult, but it's super easy. Because all you have to do now is whenever they ask for a maximum, you take the derivative and make it equal to 0. Take the derivative and make it equal to 0. The derivative then is of 20x minus 1,07x squared. So it's 20 minus 0.7 times 2, because now I just multiply this there. So it's 2,14 minus 2,14, x is equal to 0. So x is equal to 20 over 2,14, and that gives me 20 over 2.14 is equal to 2 decimal places is 9.35. 9.35 centimeters. And there we go. Look how easy it is. You get 1 mark for the derivative, 1 for making it equal to 0. So, I mean, even if you just wrote down this, you would have already gotten 1 mark for knowing that you must make the derivative equal to 0. And I mean, that wasn't even difficult because it even gave you the thing in the previous steps. You could have done this step even if you did nothing before. So guys, unacceptable to leave open spaces. Try everything, especially in your preparation. Nevertheless, thank you very much for those that attempted something. I mean, of all the students, only 3 submitted something. So to you guys, thank you. You attempted something. See you guys in another attempt. I'll send you another paper to try. Cheers. Good luck.